Hello students, welcome all of you at AriserTalent. How are you all? I hope you are doing absolutely well. So, in our previous lecture, we have discussed about some of the commercial salts that are very important in our day-to-day life. In this sequence, we have discussed about some of the salts. First salt we have taken is sodium chloride, that is known as the table salt or the common salt. Second salt we have discussed about the caustic soda. The third topic or the third salt we have discussed about the washing soda. Now we are proceeding to our next topic, that is baking soda. But before starting this topic, we will do a small discussion about this topic. Have you ever observed in the formation of the bread? We have seen a bread. Some holes are situated in the bread. So why these holes are situated? Because in the formation of the sodium hydrogen carbonate, a gas is evolved out, that is carbon dioxide, which makes the bread or the bakery item swell up. So this will be the quite interesting topic to learn about our next commercial salt, and our next commercial salt will be the baking soda. So we are on our fourth category, that is baking soda. Now likewise the other salts that are the commercial salt, firstly we will write its common name, then its chemical name, and then we will write its chemical formula, properties, process of the formation and the uses. So these questions are quite important from your exam point of view, because some sort of salt almost come in every exam. At least one salt will be there and one salt basis question will be there in your exam. So it may be either baking soda, washing soda, or many more topics we will discuss, that is plaster of Paris, which is very important from your exam point of view. Now we are discussing about the baking soda. So firstly I am writing its chemical name, then we will write its common name, then we will write its chemical formula, then the process of formation of this process. Now the chemical name of baking soda is basically sodium hydrogen carbonate or sodium bicarbonate. So its chemical name is sodium hydrogen carbonate, or its another name will be sodium bicarbonate. So this will be its general name, that is its chemical name. Now its common name will be baking soda, that is our topic. It is basically used in our kitchens for making the bakery items such as bread, toast and pastries, etc. Now its chemical formula will be the sodium hydrogen carbonate. So we can write it as NaHCO3, sodium, hydrogen and carbonate. Now we will learn the process of formation of the baking soda. So actually baking soda is basically obtained as an intermediate process of the formation of the sodium carbonate by the Solvay process. So the process that is involved in the preparation of the baking soda is actually the Solvay process. So we will learn about the process of formation. So our next topic will be process of formation. Now in the process of the formation of the sodium carbonate, this process is actually known as Solvay process. The name of the process is Solvay process. In this Solvay process, sodium hydrogen carbonate can be obtained as an intermediate product. Now what we will do in this reaction, we will take a 30% saturated solution of NaCl, and this solution is basically known as the brine. Brine is a common salt solution. Now we will start passing hydrogen gas with the addition of some amount of ammonia in it. we will obtain a product that is sodium hydrogen carbonate, and this is less soluble substance, so we can separate out it from the reaction. So what will be the basic reaction take place in the Solvay process? We have taken 30% NaCl solution, and this 30% NaCl solution is actually the brine. It is known as brine. Now what happens in this case? Firstly, we have taken a NaCl that is in the aqueous form, and in this reaction we have passed carbon dioxide gas with the addition of ammonia in it. Now what we have done, we have passed NH3 and CO2 in this process. Now this is actually the Solvay process for the manufacturing of the sodium hydrogen carbonate. What we will get in the product side, we will get NH4Cl and NaHCO3. This is actually our brine solution, and in this brine solution what we have done, we have added a ammonia and carbon dioxide. Now what happened in this case, we will obtain the products. We are obtaining the two products. First one is ammonium chloride, and the second product we are obtaining is sodium hydrogen carbonate. This is sodium hydrogen carbonate. The compound that is obtained in this equation, that is NaHCO3, this sodium hydrogen carbonate that we are obtaining in the product side is less soluble. So it is actually the less soluble, and the component which is less soluble can be easily separated out from the reaction. So it can be separated out. So this is the basic process in the formation of the baking soda by the Solvay process. Now we will deal with some of the properties and the uses of the baking soda that are very important. So before I can write the properties, you can copy it from here. Now we have our next topic, that what are the properties of that baking soda. So we are on our next topic, that is properties of baking soda. Now the first property of the baking soda is it is actually a white crystalline substance, or it will give the white crystals in the aqueous solution. So it will not show any color change with the methyl orange, but it will change into the pink color in case of the phenolphthalein. Methyl orange and phenolphthalein are basically the acid base indicators that we have already discussed in the starting of our chapter. So our first property will be, it is a white colored aqueous substance. Now what will happen in its reaction with methyl orange? It will not show any color change. So in case of the methyl orange, there will be no change. But in case of phenolphthalein, it will slightly change into the pink color. So these are the general two properties or the characteristics of the baking soda, that it will show the color change. Now its second property is, when the sodium hydrogen carbonate is heated at 543 Kelvin temperature, it starts forming sodium carbonate. It means it will dissociate into sodium carbonate, carbon dioxide and water. So it is its another property, that is, at temperature 543 Kelvin, it forms sodium carbonate. Now, what will be the reaction in this case? We have taken sodium hydrogen carbonate, that is our NaHCO3. Now we are going to heat it at the temperature of 543 Kelvin. What we will obtain in the product side? Our products will be sodium carbonate plus carbon dioxide plus water. So we can see here, this is the another property of the sodium hydrogen carbonate, that it starts giving sodium carbonate. So these are the two basic properties regarding the baking soda. Now we will deal with the uses of the baking soda in our day-to-day life. So our next topic will be the uses of baking soda. So we are moving to our next topic, and our next topic is uses of baking soda. Now, in the process of the formation of the baking soda, we have already dealt with that carbon dioxide gas is evolved, which is used up to swell up the certain bakery items like bread, etc. So its first purpose is to providing the swell up property to the certain substances. Now, baking soda is basically used in textile, paper, pulp or soap industry for certain purposes. It is also used in the paper industry. Its one application is in the formation of the compound that is called baking powder. Baking powder is actually the potassium hydrogen tartrate mixed with sodium carbonate, that is sodium bicarbonate. Now we will see the reaction of the making of the baking powder. So its first application will be in manufacturing of baking powder. So it is used in the manufacturing of the baking powder, and baking powder is what? It is actually potassium hydrogen tartrate, potassium hydrogen tartrate plus NaHCO3. So this will be the actually formula for the baking powder. Now we will see how the baking powder can be formed from this reaction. So this will be our basic formula. Now we will write here the potassium hydrogen tartrate, and its basic formula will be CHOH bonded by CHOH. This will be the basic formula for the potassium hydrogen tartrate. Now we are reacting it with the sodium bicarbonate. Its reaction is done with the NaHCO3. Now what happens in this case? The COOH will take place of the Na, and it will remain the same. Now what will be product side? It will be COOH, COONA, K will be replaced by the sodium atom, and CHOH, COOH. And the two byproducts will be obtained in this equation, that is water and carbon dioxide. So other byproducts are H2O plus CO2. So this is the basic process for the formation of the baking powder that we have discussed here. So we can say that the baking soda is used for making the baking powder. Second topic we have discussed that sometimes it is used in the paper industry, it is used in the textile industry, it is used in the manufacturing of paper, pulp, soap, etc. So these are the basic uses, and the process of the formation is basically involved in the baking powder. Now its last application of the baking soda will be in the extinguishing the fire, that it can be used as a soda acid fire extinguisher. So this will be our next topic, but you can copy it from here now. So now we can see that it is basically used in the manufacturing of bleaching powder, in baking powder, and the reaction will take place as follows. Sometimes we can see here when COOK and COOH will react with sodium bicarbonate to form the baking soda, the replacement of the sodium ion will take place, and this will be certain form of K. So we can write here, this will be CHK, K will remain K, and in case of the hydrogen it will take place of the sodium. So this will be the general equation for the formation of the baking powder. Now we are moving to our next application, that where is the baking soda basically used. It is used in a fire extinguisher, that is actually the soda acid fire extinguisher. So our next topic is soda acid fire extinguisher. So what actually happens in case of the soda acid fire extinguisher? We will take a conical flask. So what will happen in this case? Firstly, we will take a conical flask. Now we will put it in the enclosure. Now firstly we will take a container. That container will be basically made in the conical shape. So this will be our container, and container is named as A. Now what we will take in this case, we will put a knob over here. So we have taken a knob from here, and this knob is basically K. K stands for knob. Now what we have taken an ampoule in this conical cylinder. So I am taking an ampoule over here. This is our ampoule. Ampoule can be denoted as P. P is for ampoule. Now in this ampoule, what we have taken a H2SO4 that can be liberated out in case when the reaction occurs. Now what will happen in this case, we can see from here. Metallic cylinder knob K is applied, and in the ampoule we have taken a acid and we have put in this container the sodium hydrogen carbonate, that is our baking soda. So in this container what we have put it? We have put it NaHCO3, that is our baking soda. Now in this case we have provided with a nozzle. Now what actually happens in this case of the nozzle? Here we have taken a nozzle, and this nozzle is actually Z that we have taken so that the carbon dioxide gas can easily be rushed out from this nozzle and stop the fire that is spread from a small accidents. Now what will be the symbols that I have used in this equation? First symbol is our A, second K, third one is P, and the fourth one is Z. These are the basic symbols that I have used in this soda acid fire extinguisher. The A stands for the container. This container is actually in conical shape. Now after this metallic cylinder we have taken a K. K stands for knob. This is the knob which when pressed carbon dioxide can easily rush out from it. Next is P. P is ampoule. In this ampoule we have put it a gas or we have put it an acid, that is H2SO4 or some sort of other acid. Now that is the Z. Z stands for nozzle, and this nozzle is basically used to rush out the carbon dioxide gas in case of the fire accident. Now what will be the work of this soda acid fire extinguisher? Firstly, I have put it a sodium hydrogen carbonate in this conical tank. Now this is our ampoule that is called P. What we have done here, in this ampoule, now in this ampoule what we have taken the sulfuric acid, that is H2SO4. Now what will happen in this case? As soon as this knob is pressed up, this is the knob we have taken. As soon as this knob is pressed up, if I pressed up this knob, this ampoule which contain the sulfuric acid, that is H2SO4, will start breaking. Now what will happen in this case? This ampoule got break. As soon as the key is pressed up, this ampoule got break. Now if this ampoule got break, what will happen in this case? The H2SO4 will start eliminating from this knob or this ampoule, and this H2SO4 will react with the sodium hydrogen carbonate that is placed in the container, and after the reaction of both these compounds, the product obtained is carbon dioxide, and the carbon dioxide will rush out from the nozzle and stop the case of the fire accident. So what will be the reaction take place in this equation? I am writing reaction here. As soon as the knob is pressed, H2SO4 will be eliminated. This is our H2SO4. This H2SO4 will going to react with the baking soda, that is our sodium hydrogen carbonate, that is NaHCO3. What we will get in the product side? We will get sodium sulfate plus carbon dioxide plus water. So our byproducts are Na2SO4 plus carbon dioxide plus water. Now you can easily see the product obtained, that is carbon dioxide here, will be eliminated from this metallic container, or we can say that the conical container, and start flushing out from the nozzle. So what will happen in this case? CO2 rushed out very speedily, and we know that CO2 cannot be used as a gas in the case of the fire. It usually acts as a fire extinguisher. So it will, what it will do? It will do the stop small fire accident. So it means this CO2 is basically used as a fire extinguisher. So as its name, it is a soda acid fire extinguisher. Soda stands for baking soda, and the acid we have taken in the ampoule is basically the sulfuric acid. So this will be our last application of the baking soda. So in our today's lecture, we have discussed totally about the baking soda, its uses and its application. Now we are left with our two more topics, that are two more commercial salts, that is bleaching powder and plaster of Paris. These two topics we will discuss in our next lecture. Thank you so much and have a nice day.